Hey everyone, ready to dive into the world of compiler design? So today we are starting with the chapter 1, that is introduction. So to keep the things very simple, I have just broken this chapter into the 9 simple parts. So we can go step by step and build your confidence as we go. In today's video, we'll cover the overview of the translation process, understand what a compiler is and what it does. Then dive into the compiler model based on the analysis synthesis model, and then the phases of the compiler with an example. In the next video, we'll see the interpreter, overview of the linker and loader, cousins of compiler, types of compiler, right? So this phases of compiler is an important topic from the G2 point of view. It is frequently asked question for the 7 marks. So by the end of this video, you all will have a clear picture of the whole process. So let's get started with the translation process and see how it all begins. First of all, starting with the translation process, let's first understand what exactly a translator is. Translator is something which obviously translates something, right? But here in compiler design, when we are talking about a source program, right? Any program which you are writing in any of the language, okay, that will be written in the high level language, that is your C++, Java, etc., right? So this translator transforms this one type of program into another type of program, so which will be your output. So it takes one type of program as an input and converts that type of program into another type of program, which is understood by the machine, right? So there are two types of translator, which is compiler and assembler. Don't stress much, I'm just briefing you about the types of the translator. We'll discuss them in the later topics. After understanding this, right, what translator is, we can easily derive what are the functions which are being performed by this translator. So the first function which is performed by this translator is to convert one form of program into another form, which is my source program, to the target code. Okay, so any higher level language code which will be converted into the machine level code, which is understood by the computers. The second thing is to preserve the meaning of the source code. Okay, so whenever you translate some program into another language, it is obvious that you preserve the meaning of the source code. Otherwise, your functionalities or the meaning of this program will be changed. Then report the errors during the compilation. Okay, so during the compilation process or the translation process, you need to report the errors, which is a main function of the translator, and that is why compiler has the ability to report the errors during the compilation process. Okay, and maintain the efficiency of this translation. Okay, so that is, efficiency should be high. So after understanding what a translator is, let's understand what a compiler exactly is, which is one type of translator. So compiler is one type of translator, which is any program, right? That is a kind of translator which takes the input as a one type of language, which is your source program, and that source program will be written into the human understandable language, that is high level language, and it will give you output as another equivalent language, that is it preserves the meaning of the language, which will be your target program, and obviously it will be low level language which is understood by the machine. Now during this translation process, if it encounters any of the errors, as we have seen in the function of the translator that it raises the error, so if any of the error exists, then it displays an error message. So what are the factors which can affect the design of this compiler? So first of all, the choice of the source language. As you can see, the compiler is dependent on the source language. So the type of language you are using here, the complexity of the language, the time complexity, space complexity will affect the design of this compiler. Second thing is the machine architecture on which this compiler is being executed. Okay, so the machine architecture on which this compiler is being executed will always affect the design of the compiler. The third thing is amount of the memory which is being available, right? Then type of the object code which is required by the target or as an output. This factors affecting design of the compiler is not much asked, but sometimes it may asked in 3-mark question. So you can just write this 4 points. Yeah, then the major functions of the compiler. So as we have seen, the first and foremost function of this compiler is to convert the high level language into the lower level language. Okay, so the first function is converting a high level program into the machine level program, raising the error messages, maintaining the efficiency of the translation, and preserve the meaning of the source code. Okay, so after completing the what exactly the compiler is, let's see its compilation model. So during the compilation process, that is transforming the high level language into the low level language, what we first see, what the compilation process uses, that is an analysis synthesis model of the compiler. In the analysis synthesis model of the compiler, the compilation takes place into the two phases, that is analysis phase and synthesis phase. In the analysis phase, see, the word itself suggests us that the analysis of the source program is being done. So the source program, which was given as an input to the compiler, is being read, broken down into its constituent pieces, and its syntax and meaning is derived. Okay, and then an intermediate code is generated. This intermediate code is being passed to the synthesis phase, which convert it into the target program. Okay, so the source program is taken by the analysis phase, which is read there, broken down into the pieces, and then the syntax and the meaning is being derived, which is passed to the synthesis phase, and then the target, the source program is converted into the target program. So this is how the compilation is being done using these two main phases, that is analysis and synthesis model of the compiler. So this forms the base of this phases of the compiler. So whenever you are asked about this question of writing the phases of the compiler, so start with the analysis phase synthesis model of the compiler. Just draw this diagram and start with this flowchart. So this compilation process is being divided into these two phases, and these two phases have this sub phases, right? See, so the compilation process takes place like this, which forms the phases of the compiler. See, the first thing, when the source code is given as an input to the compiler, so this whole is compiler, right, which is divided into analysis phase and synthesis phase. So the analysis phase is divided into lexical analysis. So in the lexical analysis, our scanning will be done. So the source code will be read, which we have seen here, that first the reading is done, right, then breaking down into constituent pieces. So here it is broken down into constituent pieces, which we call as tokens, which I'll explain in the later. Then it is passed to the syntax analysis. After analyzing the syntax, it is passed for the semantic analysis. After that, we'll have the intermediate code generation, code optimization, and code generation. First, we'll discuss this each of them in brief, and then I'll come back to this diagram so that you get a better understanding of this compilation process and its phases, right? And the symbol table management and error detection and recovery we'll discuss in the next video, where I will be discussing about grouping of these phases, right? Okay, so starting with the first step or the first phase of this compilation process, that is lexical analysis. So in lexical analysis, it is also known as scanning, right, where the entire source code is being scanned and broken down into the group of strings, which we called as tokens, right? They are known as tokens. Now what actually tokens are? Tokens are a sequence of characters which have a special collective meaning, right? So starting with the first step of the compilation process, that is lexical analysis. So the lexical analysis is also known as the scanning of the source code, right? So the source code, which we have passed here as an input to this compilation process, will be scanned. Okay, so the entire source code has been scanned, broken down into the group of strings which is known as tokens, and the sequence tokens are the sequence of characters which have a special collective meaning, which we all know, right? Let's see an example for understanding this analysis phase. So for example, let's take one of the line of the source program. Let's say total is equal to count plus rate into 10. Okay, let's say this is my input, that is my source program. So first of all, it is scanned from left to right. Okay, so this is left, this is right, so it will be scanned from left to right. During the scanning, it will be divided into tokens. So this total will be one type of token, this equal to will be token, this count is also one token, this. So this is an assignment operator, this is an constant, or you can say identifier. This total is one kind of identifier, the rate is also one kind of identity, this 100 is a constant, the star is a sign, or you can say the operator. After the scanning has been completed, it is passed to the syntax analysis phase, that is where the parsing has been done. So the tokens generated by the lexical analysis are grouped together to form a hierarchical structure. So this basically checks the syntax, that after forming a parse tree, if the parse tree is correctly formed, then the syntax of the structure is being correct. Okay, so it determines the structure of source string by grouping the tokens together. So earlier we divided the total is equal to count plus rate into 10 into tokens, like total equal to count rate plus star and 10. So from this tokens we'll be forming a parse tree. Okay, so we'll start from rate into 10. So first of all, an assignment of so rate into 10, which is added with the count. Okay, and this is assigned to the total. Okay, so this is a parse tree, this is known as parse tree. So this checks the syntax of the source string, that is this. So if it forms that r rate into 10 plus count equal to total, so this gives you the source string. So it checks the syntax, then it is passed to the semantic analysis. In earlier I have explained that in the analysis synthesis model, in the analysis phase I explained that after breaking down the tokens, the source string into the tokens, it is the syntax and the meaning is derived. Okay, so here we have derived the syntax, now we are going to derive the meaning. So after checking the syntax in the previous phase, the meaning of the source string is determined. Here the meaning means matching of the parentheses are being matched or not. So if this exists and this does not exist, it doesn't make any sense, right? It gives you an error. So matching of the parentheses, matching of if-else statement, and type compatibility and scope of operations. So see, for example, here in this rate into 10 plus count, so here type compatibility is very important, as the rate will be, it can be in integer form or integer type or also a float type. So we need to convert this into float. So here this will remain as it is, right? So total plus count star rate, I will convert this into float. Okay, for this 10, so it will convert to 10.00. After completing this, the intermediate code is being generated and passed to the synthesis phase, as we have already seen. So we'll have the intermediate code generation here. So the type of code which is easy to generate and can be easily converted to the target code is known as the intermediate code. So the variety of forms that exist in the intermediate code is 3-address code, quadruple, POSIX, etc. But here we consider the 3-address code format. which means that it consists of the instructions, each of which has at most 3 operands. Okay, that is not more than 3 operands. So in the example we have seen, let's form the intermediate code generation. So t1, so the first term will be into float. What we are doing into float, that is 10. Okay, after that we are multiplying it with rate. So let's say some t2, which is rate into this, that is your t1. So rate into t1. After this, what we are doing is, this whole is my now t2, so this is plus with count. So let's say some t3 is count plus t2. Okay, then so this whole is what, t3, so total equal to t3, so total equal to t3. So this is my intermediate code. Okay, now what is code optimization? After generation of the intermediate code, we need to attempt to improve this intermediate code. That is, the execution of this code must be fast and memory consumption should be low. So overall the running time of the target program can be improved. After we have optimized our intermediate code, we should go for the code generation, that is generation of the target code. So here in this phase, the target code gets generated, that is intermediate code instruction to the sequence of machine instruction. So in the example what we had, so already we had the intermediate code. So first of all, let's say we move the rate to some register r1. Okay, then we need to multiply it, the 10, that is we have already converted it into the float. After this, its result should be moved to the r1, and then we need to move the count variable to this r2, and then add this r2 with r1 and store the total in the r1, so that we can move the r1 register to the total. Okay, so this is the machine level code which is understood by the computer, and what we had written was total equal to count plus rate into 10. So this is converted to this after the phases of compiler. So let's go back to the diagram. So see, in the lexical analysis, what we did was scanning. In the scanning, we converted the source code into the tokens, that was total, count. For this phases of compiler, the mainly frequently asked question in the GTO is A is equal to B plus C star 60. Okay, so alright, so that's a wrap on the basis of the compiler design, and I hope this gave you a solid start and made things clearer. So in the next video, we'll dig deeper into each phase of the compilation, that is grouping of the phases of the compiler, the types of the compiler, cousins of the compiler, and all remaining topics of this chapter. If you find this helpful, make sure to hit that like button, share it with your friends, and don't forget to subscribe so you don't miss any upcoming videos.